Hey, Sam. Welcome back.
Glad to be back. Y'all miss me?
Well, you have the honour. It could be a dubious honour, but it's an honour nonetheless of closing our wonderful conference. So you have a talk entitled C2 for you, and you're going to talk to us about command and control infrastructure. So we'd love to hear about that, and the floor is now yours, and I can see your slides perfect.
Awesome. All right. Hello again, everyone. You're stuck with me for another 30 to 45 minutes, so I'm so sorry, but hopefully you at least enjoy your time here. So before this presentation starts, again, I'm going to go through my nice disclaimer. The opinions expressed in this presentation and in any corresponding comments are the personal opinions of the original authors, not those of CVS Health. I like CVS a lot. They let me come to this conference during the workday, so I don't want to get fired. Anyway, for those of you who are new here, let me introduce myself, talk a little bit more about what I do. My name is Sam Ferguson. I'm also known as A Fine Security on the interwebs, and I work for CVS Health in their IT Leadership Development Program. I'm an IT Leadership Development Professional. It's a rotational program. I get to work in a bunch of different areas in the company. My focus is in security. So right now I'm working with our awesome orchestration and content engineering team, learning the kind of defensive side of things, how to, create detections, do detections, all that kind of stuff. But my heart truly belongs to the red and purple. I don't know if you see his purple shirt. So purple team. That's where I specialize. That's where I'm a specialist. I like anything from tradecraft, tactics, development, anything related to red teaming in those kinds of areas. I'm a big fan of. I've only been doing it since probably about June, early July. So I'm really new to it, but it's been a lot of fun learning it so far. I'm also a recent college grad. I'm new to the workforce. I graduated with a Bachelor's of Science in Computer Technology from Ball State University in Muncie, Indiana, which was a fun time and learned a lot of great stuff there. But enough about me. You don't care about me. You're here to learn about C2s. So before we get started, let's do a quick overview of what we're going to be covering today. We're going to talk about the what and why of C2s. We'll be breaking down a C2, and then we'll be going beyond the basics a little bit and see how you can further your knowledge of command and control servers outside of this presentation, because there is no way I'm covering everything about a C2 in this entire presentation. With that being said, let's get started with the what, why, and how of C2 servers. By the way, also, I will mention, I got chat open on the side, so if you want to throw any questions in there, I also see everyone. Shout out to the ROH homies. Let's go. If you want to throw anything in there, I'll be happy to try and answer some questions if I got time in the middle of the presentation, or I'll just come back to them at the end. Anyway, what exactly is a C2 server? Well, I mean, the title kind of spoiled it a little bit, but pretend you didn't see that. C2 actually stands for command and control. Obviously, C2 for short. It can also be referred to as C and C sometimes, which I don't like because I always hear it as CNC, like the CNC machine from engineering, but people call it CNC sometimes as well. So a C2 server is a centralized management of communications with compromised devices. If I had to pick one sentence to describe C2, that would probably be it. C2s establish encrypted connections that are not viewable by defenders and provide capabilities to blend in with an environment. So, why do C2s exist? Why exactly should we have them? Why is anyone using them? I have NC-TAC LVNP 4444. Why can't I just do that? There's a few reasons that C2s exist and why you see them used not only by red team professionals, but also by threat actors out there. First of all, of course, as I mentioned, centralized management, especially when you're working with a proper red team. The C2 setup, you have some sort of having a centralized location to manage pretty much any part of your red teaming process, any of the beacons that you have open, all those kinds of things, is really, really nice. And it's a big benefit to having a C2 server. Centralized utilities. C2s have a lot of functionality built into many of these frameworks. Again, we'll go into more details on all this later, but for now, just understand that there's a lot of utilities that are centralized in there. Easy collaboration. C2s, again, a lot of them are designed with collaboration in mind, with a proper red team working together, and have some people work on this this engagement at one time so people join in later, things along those lines. The C2 frameworks make it really easy for members to collaborate. And also logging and reporting capabilities. It's really easy for C2s to log the kind of actions that are taken, and especially, when you're doing documentation, because red teaming documentation is king. If you don't document it, didn't happen. Having logs available, so if you forget to write something down that you did, or you want to go back and verify exactly when something is run, you have access to logs, and that makes things a lot easier. And see, some C2s even have like custom reports that you can generate built into them. So there's a lot from a kind of a more corporate, I guess corporate the right word. Well, I guess more professional, organized setting. There's a lot of benefits that come from C2. So let's start peeling back the layers and getting into how exactly these C2s work. So I want to start off by talking a little bit about C2 communication and generically how C2s communicate between the compromised device and the actual server itself. So I've got a nice little diagram for my visual folks out there, but a quick explanation of it is that C2s use a beaconing approach. So that means they communicate intermittently. If you've done any sort of CTFs before where you have, your netcat reverse listener, you're working in what we like to call an interactive shell, where you send an action, the response happens immediately. You get the data back instantaneously. But see, at C2s, we don't like to do that, and I'll explain why a little later. But basically, they communicate at a set intermittent variable, where they'll maybe every 60 seconds you'll have your compromised device request out a job, as you can see down here, and the C2 will send that job, and the compromised device will send back the output. And they happen on a regular cadence. But of course, this can be adjusted, and we'll talk more about that later. And the data that is transmitted is likely obfuscated and encrypted if you're working with any C2 worth its salt. So, C2s are not leaving them wide open, unencrypted TCP connections. We have strong encrypted connections that are being utilized so that, our defenders can't get a peek inside to see what exactly is going on with that C2 traffic. A quick bit more about the C2 communication as well. There's various different protocols that are in platforms that might be used by C2s, because again, using just a raw TCP connection is not necessarily very common to see in an enterprise, but there are some things that are more common to see, like HTTP, specifically HTTPS, DNS, SMB. You'll probably see those being used as channels for data to be communicated from a compromised device over to a C2 server. But you can also get a little creative, and people out there have done that. You can use something like Discord to host a C2. I've seen implementations that utilize that. I've seen implementations that use OneDrive, and lots more. There's tons of people coming up with crazy ways to, turn something into a C2, which is just absolutely mind-blowing. But so if you want to try with some of these more quirky, I won't say useless, because there definitely are uses to them, especially, if organizations aren't necessarily aware of them. But, these more niche C2 platforms that communication might occur over. So we got a bit of the basics of the C2, and you might kind of have a general understanding of, how they communicate. You saw a little bit back there of the setup as well with the server and the compromised device. But we're going to start diving into the nitty-gritty, down into the technical. And for this deep dive into technical, we're going to be utilizing Empire C2, which is a PowerShell-focused C2 that is written in Python. Now, calling it I'm calling it PowerShell focused and not strictly a PowerShell C2, because they've started the Empire project people, BC Security, who's now maintaining it. They've started to add an additional functionality beyond PowerShell, things like Iron Python and C#. Love to see C# in there. It's really nice to see those things added in, and kind of moving away from a PowerShell focused C2. For those who maybe aren't familiar in red teaming, PowerShell used to be kind of the king of red team, but nowadays a lot of people like C# a lot more, because PowerShell is a lot easier to detect, and defenders are much more aware of malicious PowerShell activity. So it's nice to see those kinds of things. And Empire is really cool because it comes with both a CLI and a GUI, the Starkiller GUI. I'll show it off a little bit, but we're mostly going to be chilling in CLI. So we'll without further ado, we're going to jump right into the technical breakdown of how C2s work. But before that, I want to make a quick note on OPSEC, because I would be remiss if I didn't mention OPSEC in a red teaming sort of presentation. So Operation Security, or OPSEC, is a very critical part of red teaming. The goal is basically to prolong and evade discovery by appearing as legitimate or non-malicious. So you might have wondered, like, hey, why do we use HTTPS or DNS for our communication channels? And why do we have Beacon? Why don't we get information back just instantaneously? This is why, because we want to look like legitimate traffic in the environment. We want to blend in, evade detection, and things along those lines. So OPSEC's not a focus of this presentation. Of course, we're focused on C2, but it's going to be brought into the context of how OPSEC fits in with C2 infrastructure. So yeah, it's got to be mentioned. It's got to be brought up. And the whole goal of OPSEC, of course, is to bring your sneak up to level 100. Because if you've done any red teaming before, you know that if you use defaults, you're going to have a bad time. So we got to make some changes, because you can be sure that a lot of C2 platforms are highly signatured out of the box, and you're probably going to get caught if you don't make any changes. All right, let's jump into it. Let's talk some nitty-gritty C2 stuff. So the first thing I want to talk about is the listeners, the C2 listeners. So listeners, as the name might imply, listen for incoming connections. So, you can think of this like your netcat LVMP. This is the guy that kind of manages that part. But it also defines the expectations for inbound connections, things like ports that it's going to be listening on and that connection should be reaching out to, IP addresses, things along those lines. And there's various types of different listeners that exist. You can kind of see in the C2 communications section. Usually listeners are going to be bound to a particular type of protocol. So you might have an HTTP, HTTPS listener, a DNS listener, things along those lines. So let's actually hop into PowerShell PowerShell Empire real quick. Let me pull up my C2 here. We'll full screen it so you guys can see. Oh, and before actually, we can show this a little bit. This is a little quick look at PowerShell Starkiller, the front end for PowerShell Empire. So nice, cool platform, pretty clean, easy to look at. If you're not super comfortable with CLI just yet and you want to kind of get your bearings, this is a great way to do it. So you can see, for example, we have a listener here set up, which is HTTP. So we've set that particular type, the host address that it's going to be reaching out on. Yes, Cycling Cyber, we are doing kind of a light demo. Don't worry, all the sacrifices have been made. We're good. Demo gods will bless me in this. So, you'll set things like the port, the bind IP, and things like that to get, your basic functionality out of the way. What's going to be launched, staging key, more on this later. But yeah, this is kind of like your generic listener, and they just kind of chill in here. And I'll also note that, unlike in the netcat situation, you can actually have multiple listeners connect back, or multiple our beacons connect back to a same listener. So if you have multiple beacons using the same port 80, that'll work just fine. And we'll see how that works out later. So this is kind of a quick look over here about the HTTP listener. Let's move on back actually now to the presentation, and we're going to take a look at some OPSEC considerations for listener operational security. This is OPSEC, or operation security, sorry. OPSEC's important. So how do we take our traffic from, functional, like a C2 provides, with the port IP, all that stuff, and how do we make it look more legitimate? First thing, of course, is certificates. HTTPS, better than HTTP. Probably not going to see a ton of HTTP traffic in an organization, especially something that's reaching out externally. That's not going to be very likely. So probably want to have an HTTPS cert set up, but we might not need to put it directly on the server in a CUI later. Cookies as well, unique value that can add complexity, and there's some things we can play around with those as well, which is really cool. Delay and jitter, probably one of the more important OPSEC opportunities. Delay and jitter define how often an agent beacons back. So how long between a request for jobs, like we saw in that communication slide, happens, and the percentage variance of each interval. And I highly recommend that you utilize both of those, because if you just put on delay and leave it at that, beacon out every 60 seconds, someone's going to notice that, hey, this thing is reaching out at exactly 60-second intervals. And that's very suspicious that someone, a user might be programmatically reaching out at that time. That looks kind of odd. So adding in jitter means that, it'll fluctuate. Maybe it goes down to 49 and then it's up to like 67 and then like 58 and stuff like that. So you get a little bit of play in that area. And user agent, it's another thing that isn't mentioned, I think, a lot in listeners that I think is really important to mention because it could be an easy way to catch yourself out. If you have an endpoint in an organization that maybe the organization heavily utilizes Google Chrome, and you see in your logs that, hey, this endpoint just reached out from Firefox. Well, we don't allow Firefox in our organization. You're pretty much getting yourself caught out instantly. So be a bit aware of the user agent that you're utilizing in your environment, and just taking a look at that in here again. We can kind of see if I go into the subject here. We can see you've got the default jitter, the default delay, things like that. I'm not going to change this for the sake of the presentation to keep things smooth, but you can see what's good with that. Also, we've got cert paths here. You got your cookies here. Things like kill dates can also be nice as well in here. And then where else is it? The user agent here, obviously default. You just basically copy paste a string in there and boom, you're pretty much good to go from that perspective. So those are some operational security considerations you can make within a C2 server. So that's kind of the first step that you're going to be taking with a C2 and getting that set up. Now, there's one more thing I want to mention about listeners before we move on, and that's Malleable C2. So Malleable C2 was created by Raphael Mudge for Cobalt Strike. And if you're not familiar with Cobalt Strike, it's pretty much the industry standard when it comes to C2 servers and C2 solutions. So it's used heavily. And Raphael Mudge created something for it called a Malleable C2 profile. And it's basically a centralized place to manage operation security for that particular server. Now, this is much more expansive in Cobalt Strike. The example I'll show in Empire doesn't take as much of the utility that Malleable provides, but it still provides a lot of interesting, useful little tidbits. So you can see here, you can define everything from sleep and jitter, initial stage pull activity, HTTP request and response activity, TNS activity, memory indicators, which is much more kind of on the Cobalt Strike side of things, and a lot more. So I want to take a look at a Malleable C2 profile so you guys can get kind of an idea of what it looks like. Let me go over to my terminal here and let's pull up this comflu profile, which is in the defaults here. So let's take a look. Yeah, GJ Chester. Yeah, Cobalt Strike's so good. Bad guys use cracked copies. Yes, Cobalt Strike is that good that the actual threat actors are utilizing it. So it's good enough for them. Definitely good enough for red teamers. So you can see here we've got a bunch of values being set in this profile here. So we've got our sleep time set to 3,000. Our JIT, which is just 30 seconds. Our jitter, we've got our max DNS request. Our specific user agent that we're utilizing here. This HTTP GET request. So when the communication happens over HTTP, where that endpoint reaches out to the server, this is kind of the action it's going to take, that URL that it's going to query, the headers it's going to add, how the data that is being sent back to the server is going to be modified. So using NetBIOS and then appending this path and then appending it to the URI and things along those lines. So it's really easy to set things up. And if you're really new to operation security and you're not that familiar with, how do I set up the Malleable C2? What's the optimal thing to do? You can look at things like these, particular APTs that you want to emulate. You can pull their Malleable C2 profile. Someone's probably made it. Or you can use something like 40 North Security's C2 Concealer tool, which will generate custom Malleable C2 profiles, and you can pull that in. So really pretty easy to implement overall, and I think it's really important to mention, even though it's more of a Cobalt Strike thing, it can be utilized by the Powershell Empire platform as well. And I do believe there's other C2 platforms that take advantage of this as well. So let's keep moving on and talk a little bit about stagers. So stagers are our initial point of beacon creation. You can think of these as the actual malicious binary or DLL or whatever it is that's going to get executed on the endpoints to create our connection. Now with stagers, there's two different types of stagers. There is staged and stageless. So staged is utilize kind of uses small payloads. It's focused, the initial actual binary that you're generating that's getting executed initially is much smaller versus the stageless' larger payload. The problem with staged is that it's very prone to detection because they are heavily signatured, and there's part of the staging process is not fully encrypted, so it's easy for endpoint detection solutions to realize, hey, this is not good. We should probably stop this. Or, in the words of the great Oblivion Guard, stop right there, criminal scum, and your session will just die, and then you'll be sad because you'll have no beacon, and that would make me sad. But with stageless, even though you have a bit larger of a payload, you have a much lower detection rate. And what happens is basically it will immediately call back instantly, and you'll be pretty much good to go. Now, as far as setting up stagers on PowerShell Empire, we'll go ahead and take a look at that. I'll actually keep using Starkiller here. I think it's pretty easy to use. Now, fortunately for me, Empire started off with PowerShell and much more focused on staged payloads. There are stageless payload options. Shout out to Red Skull for pointing that out to me. But I haven't really had the time, unfortunately, to mess around with them too much to get them functioning as I would like them to. So actually building a proper stager is we're going to focus more on the staged one at this time. So I'll go in here and let's make a C# one because I'm a red teamer and I love C#. So basically you just go in, you're going to pick your listener, whatever you want it to do. Let's do this HTTP one. It'll generate, an out file, C# language, all these kinds of things. And then you can set other values, proxy, we'll get to that in a bit. More details like that. And of course, your user agent. So things along those lines, you can set all these details in here. And then all you do is just hit submit. And boom, it goes. And you can click the action and you can download your stager just from right there. And it's usually that straightforward. Stagers are pretty easy to generate. So this is pretty easy in PowerShell Empire. It's pretty easy in a lot of other platforms as well. So cool stuff from that. Now let's again jump into OPSEC for stagers. Try to be like Spider-Man and say, if we have this shirt, maybe no one will know that I'm Spider-Man. So the first thing for stagers is obviously code obfuscation, because obfuscating code is almost always helpful. Sometimes EDR solutions will have things where they'll check the entropy of the code. So if you get something that's super, super obfuscated, EDR may be like, that's suspect because nothing's supposed to be that obfuscated, and they'll mark it as potentially malicious. But for the most part, obfuscation is generally helpful. In Empire, if you do a PowerShell based stager, then you can actually get obfuscation built in there. But two other tools which focus mainly on .NET with C#, mainly because, again, I love C# and most red teamers nowadays love C#, so I'm going to mainly plug C#, is Confuser X2 and Logic.NET. So you can usually throw things like shellcode into there and generate kind of encrypted obfuscated code from that, which is really cool. And anti-detection tools as well. Optive Scarecrow. I love this tool so much. It's so good. You basically pass it in shellcode, and it will create a binary that is going to patch out both AMSI, the anti-malware scanning interface, and also ETW, event tracing for Windows, which if you're in Red Team, you know those. If you're not, those are like the two main things that endpoint detection and response are going to be using to get their data about what's going on in the system. And if you can patch those out and run stuff, you're absolutely chilling. So Optive's freaking awesome. Also, Red Skull, get out with Golang or C# slander with Go. I know you love Go. Everyone knows you love Go. So anyway, and if you're wondering how shellcode exactly works and how to generate that in PowerShell Empire, really quick, you go search it up. Shellcode, you can see Windows shellcode right here. You just pick your listener, boom, you got yourself some shellcode, and you can save it as a .bin shellcode file. So really easy, and it's pretty much that simple in a lot of other C2 solutions as well. So yeah, cool stuff from OPSEC for the stager perspective. Now, there's something that I'm not going to exactly demo in this presentation, but I do want to talk about it because it's kind of an OPSEC thing to a degree, but it's also part of the C2 infrastructure, I feel, and that is redirectors. Redirectors provide additional layers of abstraction between your server and the actual endpoint that you've compromised, because it hides your main infrastructure if it's discovered by defenders. So how exactly does this work? Well, you'll have something like a web server or a CDN endpoint or serverless, or maybe something like SOCAT set up on a server. And basically what it will do is you'll configure in your C2 settings. You saw those settings about proxy. I think there's proxy settings in there. I haven't messed around with it too much on Empire, but I know on other C2 platforms, there's usually like proxy settings you modify. And basically, you set your created stager to point actually back towards that proxy server that will sit in between your proxy server redirector in this case, that will sit in between your actual compromised endpoint and of course your actual C2 server. And what will happen is basically that traffic will get sent over to that redirector, and then it will get redirected to your C2, and it will go back and forth through that system. So if defenders actually discover you, they're only going to ever take down your redirector. Your entire backend C2 infrastructure is completely fine, and that's awesome. We really like to see that. So that's it. Redirectors are just absolutely, I think they're a must-have when it comes to C2 infrastructure. Now, a few OPSEC things that I want to talk about. Remember when I mentioned cookies back with listeners about data that's being sent over? Yeah, this is where they can kind of come in. So if an analyst is doing a cursory analysis of a domain, and you want to kind of fool them and trick them a little bit, you could make a dynamic response based on a request. So your C2 traffic is going to have that particular cookie in the HTTP header. Well, say someone goes to the site without that. Maybe you have the redirector say, oh, if it goes to this page without this particular header and this value in that header, send it back over to somewhere else or send it to a non-malicious looking page, which is huge. So if an analyst, maybe it's just the SOC analyst who's doing a quick check and they see, oh, this page looks totally fine. I guess we don't really have to worry about that. You're kind of home free from that perspective. Super nice. Some more specific things for web servers and serverless solutions like Cloudflare Workers or something along those lines. Obviously, use HTTPS. That's kind of a given. And obviously, use a recently expired domain name as well. If you're trying to consider proxy connections, because a lot of organizations have a proxy sitting in between their users and the internet. A lot of proxies are going to be a little bit suspect about any sort of new domain. So go find a recently expired domain name, buy it, use it, and the proxy will probably say, oh, this domain name's been around for a while, it's okay. And for CDNs, you can take advantage of something called domain fronting. So basically, a CDN, content delivery network, thinking of something like Fastly or Cloudflare, what you can do is basically have it make a request to what looks like a legitimate website that is served on that CDN, that CDN rather serves for. But actually, you put in the HTTP host header your actual endpoint. So when it kind of decrypts, when the CDN decrypts that TLS packet, it'll actually see the host header ended up forwarding over. So it'll even look better because now it looks like some users just reaching out to a super legit website like Google or something like that. And now no one's going to bat an eye at that. So incredible stuff. I won't go more into it, but you can look it up. It's really, really sick. It's super awesome. So that's redirectors. And again, we're not going to break it down. So agents. Let's talk about agents. We are finally getting to the actual control or command and control portion of the command and control server. Agents are your gateway to interaction with compromised devices. You can assign them tasks to be executed there. It's just basically your main hub for actually running things on a device. So the execution methods, a few that I want to kind of mention, then they vary depending on the C2 implementation of what method is used. A method called fork and run, basically, your process spawns a sacrificial process, injects injects code into it, runs the code, kills process. Process injection is injecting into another process, so you're running in a different context, which is kind of cool. So if maybe you've compromised, you're in your process and you want to move into like Google Chrome that's open, you inject into that process. And then inline execution, which is injecting into the existing process, which Empire actually does a really great job of in their modules, which I will get into a little bit later. But yeah, these first two techniques are pretty much, let's take the shell code and put it over here. So thank you, Patrick Starr, for explaining that. All right, let's take a look, and I can kind of show off a little bit of the agent. Let's get this started up. here, while that's starting, we'll jump over and kind of show, talk a little bit about agent OPSEC. So for agent OPSEC, you're going to want to look at the context of command execution. So what process am I running under, and the command that I'm executing in. Those are kind of things that you want to consider, because if you're running whoami whack priv as some process that should never interact with command line ever, something's going to be a bit suspect. Also, the types of commands that are being run, and especially the order of commands that are being run. So for example, if you run like whoami whack priv to pwd to dir, some EDR solutions may look at that process tree and say, that looks like enumeration activity. I'm going to kill this process that's running it, stuff like that. So, and then the other thing, of course, is operation hours. That's another thing that you want to be aware of, because you don't want your beacon, your agent, operating outside of normal user hours, because that would look kind of weird. So actually, let me go into my Empire here. If I can click the right dang thing. I'm really quickly going to show this because, geez, I'm taking a lot more time than I thought I was going to. Sorry, Beer Farmers. Apologies for that. But let's actually go and jump into here. I'm going to go into Lumina. I'm going to go log in. And I'm going to log in, maybe. All right, cool. First thing I'm going to do is disable Defender, because I don't want to deal with Defender right now. I didn't have time to figure out bypasses. Please don't, please don't shame me for, not figuring out Defender bypasses in time. I'm not smart enough to do that just yet. Cool. All right, so if we go in here, we can see that I have a stager pre-generated because I planned ahead for this talk. So I'll run sharpfire.exe, and if we go back, we should see that we have our nice little agent over here. Hooray! Can I get some claps in chat? We got our agent in here. Yeah, I have very secure password, by the way. So we got our agent over here. So you can see we've got you've got our interaction spot. So I can run like whoami. The shell command gets queued, and we should get some data back. Oh, pause. Hello, Mr. Agent. Maybe it's because I'm too small a screen. Let's go actually into the command line real quick. Agents acts. Also, the command line thing for this is super easy. I really like it. Yeah. So here we go. We can see the whoami results here. So we're executing commands. Hooray! We can run stuff. Super awesome. Super easy to use. And this is basically where you're going to play once you got a beacon, which is great. Let's move on now to our modules and plugins. So modules and plugins, these are what they're called in Powershell Empire, but there are other names under different C2 frameworks, but they basically extend the capabilities of a base C2. And they can be a wide range of things, of adding in new functionalities. Actually, this C# stuff that we generated over on PowerShell is through their plugin C# server. So that's kind of adding that, extending that functionality there. You can also expand upon existing functionalities or integrate existing tools into the platform. And we'll show that in just a minute here with the modules. And they're different between platforms. So for Empire, you have YAML for modules and Python for plugins. A lot of the stuff is built in. And then Cobalt Strike is utilizing Aggressor Script, which is Raphael Mudge's own custom Perl-esque scripting language. Some really cool stuff has been built out there. So it's really, really interesting. And as far as module OPSEC goes, obviously EDR insight into activities, you want to be aware of that. If your EDR can see what you're doing, probably don't want to run seatbelt because you're going to get caught, something like that. The types of modules that are being used as well, again, kind of follows along similar to that point. And also, not really OPSEC, but I want to bring this up, module functionality, because sometimes modules act really weird. Like I've had issues where, like if you run seatbelt with no parameters and it's through a module, it just doesn't work for some reason. You think it's broken, but if you add parameters, it runs just fine. So I'll go in here. Let's kind of display modules here. So hopefully everyone can see. Okay, there we go. Zoom stuff. Okay. So if I do use module here, I'm going to use the command line for this. And I want to look for, let's look for seatbelt here. So we'll do C# goes past seatbelt. And we now need to set our options. So we're going to set command here, and we're going to do brew. I'm going to do actually the antivirus because that's a typical one I like to do. And then we'll go execute. Also, you see Empire has the command completion. So again, if you're scared of CLI, this is really easy to use. Here, C# server plugin. Use plugin. C# server. Execute. I forgot to do this last time, and I did it again. Turn on your plugins, because C# server might look like it's on, but it's really not. Now it's on. So now if I go to use module, this is good. Execute. Now we should be able to run. And task it to run. Pause. Pause champ. Gonna get the callback. Maybe. You want to work today or no? Oh wait, did I forget? I didn't change this. Options. Oh shoot, use module. Use module. Use module. I'm so sorry, I totally forgot this. Seatbelt. Set agent. Let's to net40. Execute. All right, let's try this now. Maybe this will work. If not, it's demos. What do you think? Can you get the callback? Maybe not today. I guess we didn't sacrifice enough cyber goats to the demo gods. Unfortunate. It is what it is, though. But yeah, that's pretty much how you use modules. Again, that's not an Empire thing. That's a B thing. I messed something up. I know I don't have a lot of time left, so beer farmers, I promise I'm going to finish this up. Please don't be mad at me. We're going to get this done very soon. So we're going to move on, just kind of going further. You kind of saw the modules work and stuff like that. Oh, actually, before I move on, I do want to mention Empire specifically, their modules actually execute inline, which as a red teamer is freaking amazing, because if you are able to, if your initial access of the agent that you utilize, they were executed on the system and wasn't caught by EDR, and you've got EDR patched out with something like Scarecrow. Executing inline means all that stuff is also probably not going to get caught, so you're kind of chilling at that point. So anyway, going further, I want to give you a quick example of a full-scale C2 infrastructure that we've got here. So you see we've got 3 C2 servers. Two of our redirectors are actual compromised endpoint in our internal server. So on the left, you'll see, these are just kind of C2 servers that are used at different stages: your initial access, your post-exploitation, and your recovery system. Initial access is where obviously you're going to get initial access, and it's probably the one that's going to get caught most often. Post-exploitation is, any of, your lateral movement or your privilege escalation kind of beacons that you might be able to get. Those kind of go to the post-exploitation server. So the whole point is, initial access server is gone, then your post-exploitation server chilling. And then you have your recovery server, which is basically going to have a crazy long beacon interval, which basically means if all else fails, if initial access and post-exploitation both get all of their beacons killed, you can go back to recovery, get back some shells onto those other servers, and you'll kind of be chilling, not have to worry about it. All right, a couple more slides, and then we'll be good to go. A couple other C2 options I want to bring up and show off here. Sliver by Bishop Fox, Silent Trinity, Bite Bleeder, Sharp C2 by Rastamouse, Mythic by It's a Feature, Covenant by Cotter, and C3 by F-Secure. These are all really awesome platforms. There's so many options out there. There's C2 frameworks everywhere. These all actually are free, so you can go try them out right now, and I highly recommend you do so. If you're interested in learning more, because my talk certainly didn't cover all of it, maybe I did a terrible job explaining some things. You want someone better to explain. First 2 videos, Red Team Operations with Cobalt Strike by Raphael Mudge. Yes, it's focused on Cobalt Strike, but it is the noob's guide to how to red team, and there's so much value you get out of it, even if you don't use Cobalt Strike. So yeah, gotta watch that series. In-Memory Evasion by Raphael Mudge, another series I haven't watched, but I love Mudge. I trust his work. I'm sure it's a fantastic bit. And a deep dive into Cobalt Strike Malleable C2 by Joe Vest. I actually read that to help prep for this conference because I wasn't super duper familiar with Malleable C2. Knew the basics, but not some more detailed information. So I highly recommend you read that. It's incredible. It's super, super awesome. And before we end, I do want to give a few special thanks to some people out there. Dan Lucier, former manager that I worked with, giving me a chance to learn red teaming. I was just some kid who was like, hey, I really like hacking. I want to work with your team. He was like, all right, sure. So thanks for giving me the start, Dan. I really appreciate it. Red Skull for his Empire knowledge and testing random defender bypasses with me, or testing them for me in Discord. Appreciate you a lot. Raven for being a great mentor, especially for red teaming, and of course the wonderful beer farmers for a great con. And that brings me to the end. Finally, he's going to shut up. Chat, I'm going to shut up now. That's all from me. Of course, connect with me, Twitter, LinkedIn, Discord, all that kind of stuff. Feel free to connect with me there. I love talking red team, love talking general security, whatever you want. But that's it for me. I guess question time? Question time?
Live.
Okay, Sam. Fantastic. So you're, I think, the only person that's spent an hour and a half speaking at the conference today. So you win the endurance award. So very well done.
Awesome.
Could you turn off your screen share so we can get, because we've got we want to do a few things at the end. A fascinating talk, and I have to admire the energy in which you deliver. It's really infectious, and you clearly, like everyone else that's been around today, you clearly understand your subject matter very well indeed.
Yeah, thanks, guys.
So, yeah, on behalf of everybody and obviously the people that have been watching and listening in today, thank you very much indeed. Cheers for that.
Bye, guys. Thanks.
Okay.